Welcome to Lesson 6 on rates, ratios, and proportions. Your learning targets for this lesson are to be able to write and use ratios, rates, and unit rates, and also to solve proportions. So let's start off with some vocabulary. We need to know what a ratio is. And a ratio is just a comparison of two quantities using division. Go away, block. Get rid of this for you in a second. There we go. It's a ratio is a comparison of two quantities using division. An easier way of thinking of that is it's just a fraction. That's a word that you're more familiar with. So whenever you see the word ratio, you can just think of the word fraction. So some ways to express ratios, there's three different ways that we typically express a ratio. One of them is by comparing using the word 2 in between them, so 3 to 4, 5 to 6. Different kinds of advertising use the word 2. You also might see a colon between the two numbers, or you might see the fraction bar or the division symbol. A proportion is an equation that shows that two ratios are equal. So a simpler way of thinking of a proportion, remember I said a ratio is basically just a fraction. So an easier way of defining a proportion in terms that you're used to is basically two fractions that are equal. Here's an example of a proportion. To solve proportion problems, we're going to be using what's called the cross products property. And in a proportion, cross products are equal. Here's an example in numbers. The fraction 2/3 is equal to 4/6. And we can solve a proportion by multiplying diagonally those two products. So we know 2 times 6 will equal 3 times 4. That's what the cross products property tells us. In algebra, if we put letters in there instead of numbers, we get that A times D equals B times C. So let's go ahead and do some example problems. This first problem says the ratio of the number of bones in the human skull to the number of bones in the ear is 11 to 3. If there are 22 bones in the skull, how many bones are in the ears? Well, the main thing you want to be sure of when you're setting up a proportion is to put the numbers in the right place. So 11 refers to the number of skull bones, and 3 is the number of ear bones. 22 goes with skull bones, so it goes on the top, and we're looking for the number of ear bones. Okay, so if you have skull bones on top, these both need to refer to skull bones. Then we're going to use the cross products property. We're going to have 11 times x equals 3 times 22, and 3 times 22 is 66. Now x is being multiplied by 11, so we need to divide both sides by 11 to solve for x, and x is equal to 6. So there are 6 ear bones for every 22 skull bones. A rate is a ratio or a fraction that compares quantities that have different units. Examples of some rates are 100 miles for every 2 hours, 1,760 yards for every 5,280 feet, or $3 for 2 cookies. Now, you might recognize some of these things as conversion factors, and we'll get into some of those in the next few slides as well. A unit rate is a rate, but the denominator is 1. So it's a rate with a denominator of 1. Some unit rate examples include 70 miles per hour, 80 words per minute. Similar to a unit rate is a unit price, and a unit price is just the cost for a single unit, the cost per unit. A lot of times you'll see these at the grocery store on the shelf. If you look at the price tag on the shelf, it'll include a unit price. And it's a very simple way for you to compare the best deal. So examples of a unit price might be $1.50 per cookie or $2.39 per gallon of gasoline. So let's do some practice. Which is the better buy, 10 bananas for $1.35 or 8 bananas for $1.20? Well, our little monkey guy here says find the unit price of each one and compare them. So that's exactly what we're going to do. So if we have 10 bananas for $1.35, so the cost, $1.35 for 10 bananas, gives us a unit cost, and I should probably put bananas down here. That gives us a unit cost of 0.135 or 13.5 cents per banana. So we'd probably pay 14 cents for a single banana in that scenario. The second scenario is $1.20, And for $1.20, we get 8 bananas, right? So in this scenario, when we divide that out, that works out to be 0.15 per banana. So which would you rather pay? Would you rather pay 13.5 cents or 15 cents per banana? So the better deal is that one. A car travels at 60 miles per hour. How many miles per minute is this? Well, we always want to start with what we're given. We have 60 miles, and we're going to do that 60 miles in 1 hour. We want to end up with miles per minute. So I already have miles, but I need to change my hours to minutes. So I need a conversion factor from hours to minutes. Now I want the hours to cancel, so I'm going to put hours on top and minutes on the bottom. So these units will cancel, hours will cancel, and I'll be left with miles per minute. So now we just need to plug in our conversion factor. What do we know relates hours and minutes? Well, every 1 hour has 60 minutes. Okay, so we end up with 60 miles. If we multiply across, 60 times 1 is 60, and 1 times 60 is 60 in the bottom. And my units down here are minutes. Well, basically, that's equal to 1 mile per minute, right? So that's our answer. In our second example here, it says a hose sprays water at a rate of 10 gallons per minute. So we're going to start with what we're given. We have 10 gallons for every 1 minute, right? We're going to do some conversion. It says how many quarts per second? Well, I don't want gallons or minutes this time. I have to do 2 conversions. So my first conversion, I'll go ahead and convert my minutes to seconds. Okay, notice I put the minutes diagonal so that they'll cancel, and I'll fill in the numbers in a second. And then a second conversion, I need gallons, so I'm going to put gallons on the bottom, and I need quarts on the top, right? So let's go ahead and fill in our conversions. How do we relate minutes and seconds? Well, every 1 minute is 60 seconds, and over here I give you the conversion. Every 1 gallon is 4 quarts. Okay, so now we can go ahead and multiply across. 10 times 1 times 4 is 40. And I forgot to cross off my gallons here, right? So gallons cancel. So I have quarts per second. 40 in the top. 1 times 60 times 1 is 60. And we can reduce that by dividing by 10, and we would get 4 to 6. But then we can reduce that again and get 2 to 3, right? So my final answer with my units is 2/3 quarts per second. Here's a couple for you to try. Go ahead and pause the video, and I'll give you the answers when you come back. All right, hope you gave that a try. Here we go. We're going to use the cross products property. We're going to say 4 times x is equal to, so we're multiplying these two together, setting them equal to these two, is 3 times 24. Now, you might want to just write those the way I've written it rather than multiply them and getting a bigger number, and you'll see why in just a second. So if I want to solve for x, I need to divide by 4 since x is being multiplied by 4. And remember, we have to do that on both sides of the equal sign. Our 4's cancel and we get x is equal to. Now over here, the reason I didn't multiply that is I know that 4 is going to go into 24 6 times, and I have a 1 down here. So I'm left with 3 times 6 divided by 1, and that's just 18. Over on the right-hand side, if we multiply, I'm just going to say 30 multiplied by, in parentheses, x plus 1 is equal to 8 times 15 in parentheses. Again, I'm not going to distribute the 30. You could if you wanted to. You don't have to. But I could go ahead and just divide both sides by 30 since the one side is multiplied by 30. That'll help me get rid of that 30. And I would get x plus 1 is equal to, now again, 15 goes into 30 2 times, and I have a 1 up here. So I have 8 times 1 divided by 2. 8 divided by 2 is 4, right? And the last step, all I have to do is subtract 1 from both sides. So I'm going to do that, minus 1 and minus 1. So I end up with x plus 1 minus 1. They cancel and add to 0, right? So x on the left side is equal to 4 minus 1 is 3. The ratio of pencils to erasers is 1 to 2. There's 24 pencils and erasers in all. How many pencils and erasers are there? Well, here we go with our word problems. What do they tell us? The ratio of pencils to erasers is 1 to 2. So I'm going to let x be the number of pencils. What do you suppose I would let be the number of erasers then? Well, there's one pencil to every 2 erasers. So if x is pencils, I would have 2x is the number of erasers, right? So now let's write an equation. There are 24 pencils and erasers in all. So if I add these together, x plus 2x, that has to equal 24 in all. Well, these are like terms. X plus 2x is 3x, and 3x equals 24. To undo the multiplication, x is being multiplied by 3, so I want to divide by 3. And whatever I do on one side, I must do on the other. 3 divided by 3 is 1. So I get x is equal to 8. Well, did we answer our question? It says, how many pencils and erasers are there? We found what x was equal to, so the number of pencils is 8. 2x is the number of erasers. Well, if x was 8, 2x is equal to 16. So we have 8 pencils and 16 erasers. And I believe I have that hidden behind our pretty graphic there. A scale on a map is equal to the ratio 1 centimeter to 30 kilometers. So I'm going to go ahead and write that right away. 1 centimeter, write it as a ratio. Remember, a ratio is a fraction to 30 kilometers. If a distance on the map is 4.5 centimeters, okay, this is going to be equal to, we're going to use a proportion. Where do the centimeters go, on the top or on the bottom? They go in the same place. Now, when we're doing proportions, we want to line them up in the same position, not diagonally. We only use the diagonal thing when we're using conversions. So 30 centimeters to an unknown number of kilometers, or excuse me, 4.5 centimeters. Well, where did 30 come from? And then this one's the one we're looking for. So now once we have this set up, we can do our cross products. We have 1 times x, which is just x, is equal to 30 times 4.5. Well, if we multiply 30 times 4.5, we end up with 135 kilometers. Susan ran 12 miles in 2 hours during her marathon. She ran 12 miles in 2 hours. Okay? If she runs at a constant speed, how long will it take her to complete a marathon that's 26.2 miles? Well, again, this is a proportion problem, so we want miles on the top, and that's 26.2. And we're looking for the number of hours. How long will it take her? Okay, again, we're going to do cross products, so we're going to take this diagonal, 12 times x, is equal to the opposite diagonal, which is 2 times 26.2. If we want to solve for x, x is being multiplied by 12, so we want to do the opposite and divide by 12. And we have to do the same thing on both sides. So we get x is equal to, when we multiply 2 times 26.2 and divide it by 12, we end up with, oh, and I got to do this in minutes, so I better show you how to do this. So 2 times 26.2, and then divide by 12. We end up with 4.36 repeating. So here's what I got on my calculator. Whoops. Grab that. 4.36 repeating. So maybe it would be better to do this. This is 6, right? And then, so I have 26.2 over 6. I'm going to divide both of those by 2, and I'll get a 3 down here. And what is that? 2 divided by this is 13.1. So it's really 13.1 divided by 3, which is the same as 4.36. So I know this is the number of hours, right? So I have 4 hours, but I also want to get this into minutes. So here's a conversion for you. I have 0.36 repeating, so I'm going to do this over here. 0.36 repeating, and that is hours. I want to convert that to minutes. So I need one conversion factor, and I want hours on the bottom and minutes on the top. And what's our conversion from hours to minutes? We have 1 hour is 60 minutes. So if you take this decimal, 0.36, and multiply it by 60, we end up with, that's where the 22 minutes comes from, okay? So that number you end up with is your number of minutes. So it's 4 hours and 22 minutes. And that will do it for this video. We'll see you next time.